Alright, welcome back everybody. In this video we're going to look at the development of Euler's formula, one of the many things known as Euler's formula, using some of the Maclaurin series that we talked about previously in the last lesson, and extending their use to complex numbers. So let's start here with example 1. We're going to use the Maclaurin series for e to the x, and we're going to use that to find the Maclaurin series for e to the ix. Now remember that e to the x, the Maclaurin series, is 1 plus x squared over 2 factorial plus x to the third over 3 factorial, etc., etc., etc. And so if we want to take that series and write a series for e to the ix, all we're doing here is replacing x with an ix at every location. And so this becomes 1 plus ix plus the quantity ix squared over 2 factorial plus the quantity ix to the third over 3 factorial plus the quantity ix to the fourth over 4 factorial, etc., etc. And some interesting things happen when we develop this series. If we look at the expansions of each of these terms, we can now write this as e to the ix equals 1 plus ix. And then if we think about the term quantity ix squared over 2 factorial, that's I squared x squared over 2 factorial, and we should all know that I squared is equal to negative 1. So in fact, the complex portion of this term disappears. We replace it with a negative 1, and this becomes negative x squared over 2 factorial. And then we'll do the same thing with ix to the third. That's I to the third x to the third. And I to the third x to the third becomes negative I x to the third. And then we do the same thing with I to the fourth x to the fourth. I to the fourth is equal to 1. So this just becomes plus x to the fourth over 4 factorial. And then we start to see a repeating behavior in these. I to the fifth is just negative I. Or pardon me, I to the fifth is just I. So this becomes plus I x to the fifth over 5 factorial. And we continue to generate our terms like so. Alright, so there is a series for e to the ix. Now, if we go down here into example 2, we're going to use this result that we have here and the Maclaurin series for sine of x and cosine of x to prove that e to the ix is equal to cosine of x plus I sine of x. So first of all, think about the series for cosine of x. That's just 1 minus x squared over 2 factorial plus x to the fourth over 4 factorial. Etc., etc. And the series for sine of x is x minus x to the third over 3 factorial plus x to the fifth over 5 factorial, etc., etc. And therefore we can develop, since we have the series for sine of x, we can develop a series for I sine of x by just multiplying every term of that by 1. So this becomes ix minus ix to the third over 3 factorial plus ix to the fifth over 5 factorial etc., etc. And so what you should notice from this, if you're really paying attention here, you should notice that if you look at the series up here in example 1, all of these even-powered terms that don't contain i's are exactly the terms of the series for the cosine of x. And all of these odd-numbered terms, which are the ones that contain i's, are exactly the terms from I sine of x. And therefore, by adding these two series together, we get the series for e to the ix. Alright? And this is what we're talking about when we're talking about Euler's formula here. This formula that e to the ix is equal to the cosine of x plus I sine of x. Let's delve into example 3. Use Euler's formula to prove that e to the I pi plus 1 is equal to 0. Well, Euler's formula tells us that e to the ix is equal to the cosine of x plus I sine of x. And so e to the I pi let's show it this way. E to the I pi plus 1 is equal to cosine of pi plus I sine of pi plus 1. The cosine of pi is equal to negative 1. The sine of pi is equal to 0. And so we've proved that e to the I pi plus 1 is equal to 0. Alright, that's where we're going to stop for this video. If you come back for the next video, we'll look at some examples of utilizing Euler's formula and simplifying some expressions. Just, kind of a neat little thing we've got going on here. Alright, see you next time. Have a great rest of your day.